close your eyes right now and visualize something for me. All right, now imagine that you are lying on your back in a grassy field and you're looking up at the sky. Now you see these sparkling orbs of light on a big backdrop of void, and you think to yourself, you know, the universe is so vast and I'm so small, and could there be someone out there, you know, looking down at me, doing the same thing that I'm doing right now, just on a different world, and I could never tell because they're so far away. And then, of course, you know, the ever-present thought, what should I have for dinner tonight? Well, I want you to try and convince you that there is life out there, and that it's technologically advanced, just like us. Now, of course, you're probably thinking, oh, William, there's no aliens, there's no little green men out there, and then, you know, you lovingly pat my tinfoil-laden head until, you know, scoot me off to wherever. Well, that's where I come to this. Now, this is the Drake equation, and this is used to calculate the estimated amount of technologically advanced societies in the Milky Way galaxy. Now, n represents our finished value, which is the number that we get. Our star here is the total number of stars in our galaxy, which is roughly 400 billion. Fp is the percentage of those stars with planets orbiting them, which is about 25%. Ne is the number of planets with the possibility of life in those solar systems, which is about 2. Fl is the probability of life arising on that planet, which is 50%. Fi is the probability of intelligent life arising, which is about 10%. Fc is the probability of a technological society arising, which is 10%. And then L is the percentage that the technological society is alive in the planet's lifespan, so that essentially the planet is still, you know, supporting life. Now, this last figure is debated upon. It's estimated to be between 1/1,000,000th and 1%. Now, depending on what you decide L is, n is equal to either 10 or 1 million. All of this information comes from the SETI Institute, which is in charge of monitoring our skies. They operate large satellite dishes, and the Space Hubble telescope and different things like that. Now, what this all means is that there is roughly 10 to 1 million technologically advanced societies in existence in space at this very moment. Now, these are numbers and figures, and they don't feel real to you. I'm sure at least they don't. Which is where I come to my next point. According to NPR, we have discovered an Earth-like planet that we have lovingly dubbed Kepler 22b. Now, Kepler 22b is about 2.5 times the size of the Earth. The orbit is a little closer to its star, which is actually a duality star, which is two stars orbiting each other. Its orbit is a little closer to its stars than Earth is to our sun, which makes it slightly warmer on average. It goes around its orbit about every 290 days compared to our 365. Its estimated surface temperature is about 72 degrees Fahrenheit on average. So it would actually be quite comfortable to live on this planet. At this particular moment, we don't know if it has water on it because we can't exactly get to it, seeing as it's 600 light years away. In astrological terms, 600 light years is not all that far, but we don't have the advanced technology to actually get there, or even really to look at it. The reason that we know that it's there is because we can see, we look at it with our Hubble Space Telescope, and we see its stars, and we can see little shadows going across. And based on the size of the shadow, we can determine that it is there, and that it is the right size and the right distance for the possibility of life. Now, it may not have life, and it may not have the right kind. Now, this planet could just have, plants, which would be great. That'd be wonderful to find. Now, on astrological terms, essentially, this planet is in our backyard, but we probably won't be getting there anytime soon. It's roughly estimated that we should have the technology to perform an expedition in about 200 years, and all of this information comes from NPR, as I said before. I hope that my ramblings about this were coherent and informative, and that you may have reconsidered that age-old question of, are we alone in the universe?
So, Oscar, tell us what you thought.
I like the attention grabber. I thought it was quite unique compared to the rest of them. The topic I thought was really good. I personally think about that sometimes, and I got my attention a lot. His introduction wasn't as clear, I thought. He just kind of was kind of a little too broad and didn't really specify that as he was talking about it in the speech. He has good information, cited good citations. I feel like his eye contact was a little inconsistent and was kind of talking to the board more than to the audience. But other than that, I thought it was a good speech.
Okay. Yeah, I kind of like a couple of things. You know what, the math equation that you put up there was probably necessary to explain the concept, because it would be hard for us to follow as we were listening to it. You're not really supposed to have visual aids, but I thought that the way you set it up and then you say, don't worry, I'm not going to have you do math, I think most people can kind of relate to that. They appreciated the humor in what you're talking about, makes it easier to relate to what you're discussing there. And of course, organizationally, as you're explaining the concept, it's a lot clearer because we can follow all of the steps in the process. In the rest of the speech, I didn't think it was quite as clearly structured, but that doesn't mean that it was hard to follow. It was actually pretty easy to follow, but I do think that you need a little bit stronger setup of what the content is going to be, and that your supporting points could be labeled more effectively. But the explanations are always very clear. I thought you did a good job on that. The citation of supporting material was pretty good. The Drake's equation you explained well, and then the material from NPR. I don't know that those are always direct quotes. It sounds to me like some of them are just kind of FAQs on bits and pieces of information. How anybody figures that we'll have the technology in 200 years to be able to do this, I'm not quite sure. That seems to me like it's pretty darn speculative too. The equation made a lot more sense, and then the example that you're talking about, whatever it was, Kepler 22b or B222, the name of that planet, I feel like I ought to write them a letter and hope that they respond, but obviously that's not going to happen. You did a good job delivering for the most part. I think if I listen to you, it's really good, because you've got a good quality in your voice that sounds like it's having fun, it's relaxed, it's interested in what it's talking about. You're trying to make it interesting to listen to while you're speaking, so you did a good job on that. I've got to kind of agree, though, that your eye contact's a little inconsistent. You've got those big pages in your hand that you're waving around. That's distracting. And like we said earlier, like Oscar said, sometimes you're turning the board, sometimes you're looking at the pages, sometimes it's off to the side. I think if you talk to us, it would be a little bit more, Gesundheit, a little bit more convincing. All right.